Working again. Working yeah. Different company. Like everything checked out, and then as soon as I started running. Very close to the wire back. Actually, really scary. We already have to think how to get into everything out. Like, there's no light. There's no sense. 30 seconds for this. Yeah. You know, you're not doing it like this. 3 days when you no, the problem was that I opened the enclosure. Like I'll start and have 3 days in
Thanks for the meeting. We basically do these meetings once a month, and it's sort of like a miniature show and tell. Last month there were like 3 people here, and this month there's a whole host of people here. So I have no idea unless they got called out apparently. Bob is coming to us remotely and is I think going to start the meeting off. Basically, people give short talks. I think we have 3 or 4 of them tonight about projects they've worked on and things they've done. And at the end, we can go around and can say who you are or what you're interested in or why you're here. Otherwise, my God, it's Mr. Peter from afar.
Oh, like
been many years. Anywho, Bob, you want to take it away?
Okay, can you hear and see everything okay? All right, cool. So I'm going to talk about my DIY residential solar installation. This was my house back in August, and the roof needs to be replaced. The shingles are, we don't know how old they are, but the I am motivated to get solar installed, and part of that is usually you replace your roof immediately before putting a solar in, because removing the solar panels in order to install a new roof is expensive and time consuming. So you want to make sure that you have a brand new roof. So we wanted to do a metal roof because those last a really long time. They're recyclable. They are better for the environment. They're safer. They end up in the long run being cheaper. So it would cost about, well, it ended up costing us around $18,000 for a new metal roof, but to do it in shingles would, and it lasts for more than 50 years, but to do it in shingles, it would have, we would have had to do it twice at least in that 50-year time span. And so ultimately it would have been more expensive. But anyway, this is what so we got a metal roof. And they put in a ridge vent along the top, which actually ended up saving us on cooling costs almost immediately because the attic was better ventilated. And so we could immediately tell a difference. But this is a standing seam metal roof, which means there are essentially just those 2 vents. Those are the only penetrations on the entire roof. So what that means is for each each panel, there's the side that has the screws in it is on one side, and that is covered by the other side, which snaps over. So there are no exposed fasteners. And one of the benefits of this is that there's no way for a leak to happen. because there's nowhere for the water to get in. So with this new metal roof, we ended up getting a huge deduction on our homeowner's insurance as well. So that was nice. And it looks clean and is easy to maintain. And really shortly after we had our roof installed, oh yeah, this is the top side of it. But really shortly after we had our roof installed, there was this inch-sized hail. And it was not louder for us than anyone else. They actually leave your shingles on when they put the metal over it. And even this size hail didn't have any, like there was no dimpling or anything on our roof. So it was funny as all of the roofing people came by and were like, hey, you want a new roof? We're like, well, first of all, there's a no soliciting sign on our door. Second, we just got this roof. And third, it's a metal roof, go away. So the timing for this hail was actually perfect for us because it was right after installing a new roof and right before installing the solar panels. Although the solar panels should not have been impacted like negatively by this size hail, it was still nice to be safe. So this was the part that I did not DIY. We had someone else do the metal roof installation. And as another bit of prep for the installation that I did, a little over a year ago, I installed what's called Emporia View, which is a current monitor that has a whole bunch of sensors that you put on each of the circuits, and two for the whole house. So this way I was able to monitor exactly how much current we were using throughout the entire house. And not only did I find some vampire loads and eliminate those, but it gave me a sense over the entire year of how much power we were using and where it was going. So that when I was doing my solar panel like budgeting, I knew exactly how much I needed. So I would highly recommend doing this if you're gonna do solar panels. Just to, I mean, you could look at your utility bills to see how much you're using each month, but I really liked the resolution that this gave down to which individual things in the house were causing the most consumption. And so what I found was that we were averaging roughly 15 kilowatt hours a day, which ends up being around 5.5 megawatt hours a year, which is really not terribly bad. We're most of our consumption is from the dryer actually, and during both Danielle and I work from home, so our power consumption during the day is like because we're working. So anyway, this gave me a good idea of how much power I was using so that I could start budgeting for my solar install. So the next step is to go to PV Watts, which is a free utility put on by NREL, which is the National Renewable Energy Laboratory. It's in Colorado, I think. Anyway, what they do is you put in your address and they have some calculators that show how much energy you can expect to get based on your system that you're planning to install. So I was looking at maybe a 4 kilowatt system, which would have produced about 5 kilowatt hours per year. That's slightly less than the 5,500 that we were expecting, but we also figured that we would reduce our AC consumption a little bit during the summer because of our new roof. And it doesn't make any sense for us to get more than 100% of our power consumption taken because you're basically wasting money at that point. So there is net metering in Madison, which means that basically the utility acts as your battery. So in the winter, when we're not producing very much, then we are pulling more power from the utility. But then in the summer, when we are producing way more than we're consuming, then we will be banking that extra power that we're putting onto the utility. So over the course of a year, it ends up working out roughly equal. And And so it doesn't make sense for you to buy more solar than you will need, because then you're just selling to the, then you become a net producer, and the utilities don't like that. Like MG&E doesn't like for you to become a net producer. And even though they pay you, it's at way lower rates than it's worth. So it's not cost efficient to buy more solar panels than you will consume. But anyway, what I found was that a 4 kilowatt system was roughly pretty much the sweet spot for us, which is great because that's how much roof I had. So the next step was I went to a wholesale company, and they sold us basically a kit. They put together a plan set, which included a whole bunch of documentation and a list of materials. And they ordered the materials and combined them and put them and sent me a couple of big boxes. That arrived in 2 shipments, but yeah, once all the stuff got here, it was up to me to do all of the rest of it. They just gave me the parts and the plan set. So this is the system that they designed for me. And it's not really that they designed for me, they just copy pasted this and made whatever changes they needed for my specific system, but they do this all the time. So it was pretty quick for them. But anyway, we have 10 solar panels that go to a junction box and then down to the communications gateway, or the combiner box is what it's called. And then from there, it goes up to the external disconnect switch, which is required for all solar installs. And then it goes to my main panel, where there's another circuit breaker, and that provides power from the solar system onto the service panel. So it's called backfeeding because the service is going from the solar through the breaker, basically backwards into the panel. And so that's the system that I was supposed to install. And then as far as the layout of the panels, I was really confused here because international code or fire code says that there needs to be a 3-foot access path on at least 2 sides and 18 inches across the top. And that's for access in case fire needs to get at the roof. However, if you look around in Madison, there are basically nobody follows this rule, and they will put it all the way to the edge if they can. So I don't know what's going on with that. But the company that put together my plan set didn't want to do anything outside of this. So 3 feet is what I got, which when you're installing ends up I don't know how I would have done this install if I didn't have that space to move around in. So I'm glad that I had it. But there are 2 small holes in this layout. One is because the stack for the what's it called? Chimney was encroaching on this space, so we couldn't fit a panel in there. And the other is the sewer stack. So anyway, that's the layout. And then there's the bill of materials, which probably looks very difficult to read from your perspective, but it's all of the parts that I needed to install. And they only sent me a fraction of this and then relied on me to go source the rest, which was a little annoying and required a few trips to Menards. So I sent the plans off to the City of Madison, and they came back pretty quick. Well, no, after 3 weeks, they came back, and because it took them 3 weeks to even get to reviewing my plans. But anyway, so they came back and said, your plans need to include structural information for the roof and calculations showing the roof can support new load points or new point loads on it. And so this was news to me, but I sent him some pictures, and this was one of the pictures. So what you're looking at here is the ridge beam, and there are rafters on either side of it, but the rafters to the left are at 45 degrees, and the rafters to the right are on the flat part, and those are at 12 degrees. But specifically, look at where the rafter meets the ridge beam, and you'll see that the rafter is cut at 45 degrees. And so it only touches the ridge beam in like at the very tip. And there's those two nails that are just hanging out. It looks like at one point the rafters were both at 45, and then they tilted it up so that they could install more floor area on the second floor. And then they just put in some 1x8s to scab onto it to hold the rafter onto the ridge board. So the city, once they saw this picture, were like, it looks like your roof has been severely compromised at some time in the past. I would strongly recommend fixing the rafter end connections before putting several $1,000s worth of solar equipment on the roof. So at this point, I freaked out and enlisted the help of Sean at Sector and started exploring options. I was very worried because this would not be an easy problem to solve. And all of the solar stuff was already in our garage, and it was October and getting colder. And I really wanted to have everything installed before it started snowing. So I modeled up the entire roof in SolidWorks and started playing around with some calculators. I was trying to figure out how I could solve this problem without taking the roof that we had just had installed off. And so what I came up with was a plan that used really expensive 2x6 rafters. So these are MSR 2400. So if you look at ratings for lumber, it comes in like number 2, number 1, premium, and a select. And then there's this MSR, which is machine stress rated. So each rafter was individually tested with a machine to make sure that it had the appropriate strength. So these boards were like twice as heavy as the kiln dried and twice as expensive, but they were capable of doing the 13-foot 6-inch span that I needed. And so I submitted these plans to sister each of the rafters, and there were about 20 of them. And the city approved my plan, and so I could move ahead on doing the sistering. Oh, there was one other part that I needed to do to test out, and that was uplift. So the attachment points are these S5 clamps, and they clamp onto the standing seam. So they're capable of, except the documentation on them showed a huge number of pounds that could be pressed down on them, but there wasn't any number for up, which is important because of a uplift, which is where basically your solar panels act like a sail when the wind is blowing in the right direction. So I basically developed my own test of the uplift capability of these S5 clamps with 120 pounds of weight on a single clamp, and showed that the screws would fail before the clamp did. So I started, once the plan was approved, I started installing the rails. So the rails just, I don't know, they're rails, not very exciting. And I worked on the roof with this ladder. So you'll see the ladder is on top of a picnic table. And I built this picnic table a few summers ago. It is rock solid, I promise you. It does not move. So it was pretty safe. Although not OSHA compliant, and later when the inspector came, she did not want to get up on there and allowed me to go up and take pictures and show her. But anyway, so to get the solar panels up, I was pretty happy with this solution. I took 2 of the rafters and laid them against the roof, and then hooked onto the solar panel, which is wrapped in a blanket, and then went up to the top of the roof and slid it all the way up. And it was super easy. This was possibly the easiest part of the whole installation, was getting the panels up. But yeah, each of the panels went in place, and there's two clips or two connectors that clip right onto the microinverters. So, and each of the microinverters was installed just underneath each panel. And one cable with connectors already on it strings from one to the next. So it was super simple. Like if I was just doing the solar part of this, then this would have been like a 2-day project. So that's me pretty happy that I've got the solar panels all on and the microinverters, and everything is good to go, and it is still like there's still leaves on the trees. So I was cutting it close, but I did it. But there was still the sistering of the rafters to do. And this took maybe 25 hours of work inside of this attic, where I've only got 2 feet of space at the maximum. And I'm moving among the rafters, sorry, the ceiling joists, where basically I ended up with bruises all up and down my because of putting pressure on those very small ceiling joists. But I wore a Tyvek suit and a respirator and gloves the entire time, so I didn't really have any problems with the fiberglass like itching. But it was extremely hot, and so I was sometimes feeling like I would drown in my respirator. It was no fun. And so the way that I got those rafters up into the crawl space in the first place was there's this vent up here, the gable vent, and I took it off, and then I would take a rafter and put a nail into one end of it and lift it up and hook it onto the vent, and then go upstairs and grab that end and pull it so that it was horizontal, and then slide it in to the attic. And then it was at the wrong angle, so I had to rotate it 90 degrees into the correct bay and slide it into place. Each one took at least half an hour to just get it into place. And then it was a matter of using a bottle jack to lift it up and take the pressure, take the weight off of the previous rafter and put it onto the new rafter, and then put a screw or a lag screw in the end through the ridge board so that it would suck the rafter up against the ridge board. And then from there, I would put holes in every 16 inches to then put lag bolts through and sister the old rafter to the new rafter. So you can see that vent in the back behind my head where all of the rafters came in, and then I moved them and put them into place and sistered them. It was a huge pain, and when the inspector came to look at what I had done, he was thoroughly impressed and amazed that our roof had actually been standing this entire time. So it was a huge effort. It was terrible. I don't think anyone else would have done this. It probably would have been easier to just remove the whole roof and put in new rafters from the top, but this is what I did. So once that was approved, then I could move on to the electrical work. And that I did, actually, no, I got the approvals all at the same time. But once I was done with the rafter work, I moved on to the electrical. And so we've got the junction box where it goes from the solar panels cable into just normal THWN or TWHN, whatever. Anyway, so it's wires that go down to this down the side of the house, and so we're looking at this left one. So that goes down into the house and to the combiner box, which is the N phase one on the right. So I could have put the combiner box above or just next to the meter, and it would have saved me a lot of piping, but it would, so this particular spot is in the sun pretty much the entire time, and it's a plastic box. So I didn't want the possibility of it degrading over time. Also, if I plan to install solar panels on the garage in the future, then it will be more convenient for the combiner box to be in the basement. So those were the big reasons why I went the way that I did. So it goes from the roof down inside into the basement to the combiner box, which looks like this on the inside. So the solar panels go in and then into the breakers and then back out to the external disconnect, which is right here next to the meter. And then from the external disconnect, it goes back down and into the main service panel, where it goes into a breaker that then powers the house. So just by flipping that external disconnect, you can disconnect the solar from the house. And that's really important because if there's a power outage, then we don't want my system putting power back onto the grid and possibly electrocuting a line worker. Right, so at this point I had the inspection done, and the inspection of the rafters went great, and he passed me with flying colors. The inspection of the electrical part, I actually failed the first time for a couple of really simple things. One was my washing machine was too close to the service panel. You need to have 36 inches of space, and I had like 28. So I actually had to buy new washing machine hoses so that I could move the washing machine over by another 8 inches. It's a silly thing. I knew it was going to be a thing, and it was kind of a crapshoot on which inspector I got, whether they would enforce it or not. The other reason that I failed was my external disconnect. I had swapped the line and the load. And it turns out the solar panels are considered the load side, and the main service panel is considered the line side. So I had swapped them thinking that, well, solar panels are a line and everything below it is a load, right? But no, that's not how they look at it. So I just had to swap swap 4 wires on the external disconnect, and it was easy. So she came back like 2 days after she had failed me and gave me a pass with flying colors, and told me that I did a great job for a first time and a spectacular job for a DIY person. So now that everything was installed, I could tell MG&E, and they had already approved my plans and had replaced my meter with something that could do bidirectional. So all they needed to do was sign the contract, and this took them an agonizing week to do, where I couldn't turn on my solar because I didn't have the signed contract from MG&E, but it was just sitting there waiting, and I really wanted to generate electricity. But once they did give me the approval, I turned it on and started generating power. So this is all of the power that I've generated over the last, well, 2 weeks-ish. Pretty exciting. It is, yeah, this is showing the actual power being generated over the course of the day. We're only getting power from like 9 to 3. But when we are, it's pretty decent. It more than covers what we're consuming during the day. And this is winter, where we know that we're going to be at a net deficit. But when summer comes around, we'll be producing way more power than we're using. So to summarize, we're getting lower power consumption because our metal roof and better venting, which is great. The total cost ended up being around $11,500, which after the 30% tax incentives becomes around $7,000. And that means that looking at our bills and assuming about 16 cents per kilowatt hour, we'll break even in about 8 years. If power costs go up, then we'll break even sooner than that. So I'm overall pretty happy. The solar part of this was easy. Like all of the preparation for it was a pain. All of the logistics and getting the permits and especially the rafters, that was a terrible experience. But the solar installation part of it was pretty straightforward. I would definitely recommend to other people getting solar. So with that, are there any questions?
I have 3 questions.
Davie, one at a time.
One at a time. Did Enphase give you any sort of idea of how long those microinverters should last?
No, but I expect that they will last at least as long as the panels.
So I wouldn't expect that. I've already replaced the set. It wasn't Enphase, but my understanding, my brother's buddy runs a commercial solar install company. He told me that microinverters, macroinverters, whichever way you've got, last 8 to 13 years. So just heads up that this isn't a forever system. You know, there's maintenance involved with anything. But I'm really curious about your disconnect for your power. You said that you don't have to run out there and flip that disconnect when the power goes out, do you?
I had the same question, Bob. Like, so let's say the power went out in your neighborhood. Does MG&E expect you as a homeowner to go flip that switch, or
No.
should there be another safety somewhere in that system?
Right. So the combiner box is also doing some of the work. It is monitoring the utility power and won't generate and won't let any solar power through unless there is also utility power at the same time. So
There's text for the fire department.
Yeah.
So, okay. Yeah, shut it off for response.
yeah, so it's a grid tied, which means I don't get any power if there is a power outage.
So I don't think this would just Mark, Bob. I'm curious what happens if, let's say, the power goes out for 2 weeks, like it never does, but it has in the past. Are you able to access power from your panels with this system? Because I know there's a couple of systems in the world where you can and some that you can't.
Yeah, so the microinverters that I chose are the IQ8s, which have the possibility of grid forming. And there is a feature called the critical loads, where you can have a separate outlet that can be powered when there is solar available. So it is possible, but it is undocumented and I can't find any way to get it to happen. So it's something that they advertise, but it's not something that they allow really. So you are correct that if the city is out for 2 weeks, then I am also out for 2 weeks. In theory, it is possible, and I imagine I could round up some supplies at Sector that would allow me to fake a grid that would then make me an off-grid site.
Yeah. So you don't have to answer. Just curious. Did you have the home inspected when you bought it?
No.
Okay.
What on like the 26th and 27th of November, you didn't have any production? Was that snow or clouds?
Correct.
It was both.
Yeah.
Any other questions from anybody?
I'm curious, and I'll probably get the long story from Sean here, but when you connected the old rafters with the new rafters, it looked like a scab of plywood at the end. What was that all about?
That's a big one.
Go ahead, Sean.
Well, so I looked at this room with Bob to help him from or do a couple of things. As far as I could tell, just from the age of the wood and the way the text was made, I almost felt it was very likely that when that house was first built in the 40s, 50s, somebody changed their mind at some part before maybe the house was finished. And just because of the scabs that were used, you saw those little 2-foot pieces of line. That's what actually was transferring the connection.
Oh, that's original.
That was original. Yeah, so that's one. So if you looked at Bob's photo, where you basically, literally, it wasn't a traditional gable pitched roof. and they just lifted one side of the roof. And that scissoring action, they had to like kick back. So I mean, honestly, it's a testament to the strength of nails and to how little you really need to plan. But like I said, I don't think that was approved. I mean, if it was a remodel, it was really old remodel, which means that thing's been like that for 50 years.
I was just appreciating, Bob, you up jammed in the attic way with like a foot above you, and just contemplating like, well, you put all this extra solar load already up there, so you get squashed by your own $11,000 panels. So, I mean, granted, snow load, of course, is the actual load, but it's just interesting. Never a dull day.
Yeah, that was definitely a concern for me as well. But I did I actually put in some of the rafters before I started putting on the solar stuff.
Plus to figure out if you can actually do it, right? If the process works to get the wood up there.
Yeah, I actually bought a couple of regular kiln dried 2x6 rafters just so that I could practice with the correct cut angles and length and getting it into place. So I did that first before I started cutting my expensive headers.
Anybody else have anything else for Bob? Otherwise, we're gonna cut Mr. Bob loose and Richard's up next. Thank you, Bob.
Yeah.
Thank you, Richard. I'll share the screen here. You want me to play this first? Or?
Yeah, go ahead and play this. So this is I can talk.
Yeah.
A gallery I show at Stoughton, Davie, contemporary gallery. They have a space on the second floor that they set aside for more experimental installation art. So I got a chance to do something here that's up until the end of the year.
So if people want to see it, where can they go?
It's in Stoughton. Able Contemporary, it's down by the railroad tracks past the Opera House. It's in an old tobacco warehouse. It's worth the trip. It's a nice gallery. It's a beautiful building. Actually helped them renovate it. So 4 years ago I stopped. I just flew the class. Quit that 4 years ago, and so I had time to do a lot of other things. Still wanted to work with glass, so I've been experimenting with what I can do with bound glass, flat glass. It doesn't involve burning fossil fuels. So everything in this show was either found or already had. Except for like some paint, some hardware. And I wanted to build a room that you could walk inside of. And so I wanted it to be kind of scavenged together, rickety. I didn't know how to design it, so I built that like how do you build something that's kind of scabbed together? Well, I figured it out as I went along. So I built it in my studio, and then I rebuilt it in here, and I figured out the hardest part was I wanted to have these fans. My first idea was to have a hand crank it. You became the motor that actually made the whole thing kind of like fly apart. But that was too complicated to figure out what time I had. So I had these fans laying around, and I realized that I couldn't just have them come on and off, so it would just kind of look through windows, would go back. So I needed more turbulence, basically. So I put two of them on a 5-foot bar that had a pivot in the middle, and then just put a screen door spring on it, so they would spin 180 degrees or half a circle, and hit a break at a 15-second motion, or like you have when you go in those smaller shoulder numbers. So it come on for 15 seconds, and then the spring would bring it back. It was pretty simple, actually. I had to monkey around with a lot of the spring to figure out how to get it to actually wrap it around the curve. And then the other part of the exhibit is, yeah. So the panels were, these are all salvage windows. And,
Good luck.
Actually, when I started the project, I have a sandblaster in my shop, but my compressor went out, so I ended up doing most of it here. So I sandblasted them, I rubbed ink in them, and then all the black part is done with a 4-inch diamond wheel on a, we call it lathe. It's like a pitch grinder. So that texture is all hand done by engraving them, and then I rubbed ink in, and I took off sand block some of the glass to get that texture. And then the rest of them were done mostly with either a Dremel type tool or actually a angle grinder with a diamond pad. And then the other part of the exhibit, the other thing I've been working with is this is a engraved piece with a mirror. Found a whole bunch of mirror in a dumpster. So I wanted to, I cut them all up in the shapes and sizes of icons and kind of stuff, and I started engraving the front and the back. So that's like that's actually the size of my desktop. Here's this is bracket. Kind of disformed. I go to the front picture right there. When I was up in north of Menominee Reservation, area where I keep about 5 years ago, I think they got a pure line wind that came through there and it knocked down all this area. So and the brackets are just old aluminum screen window, storm window things that I cut up, manipulated brackets to hold. I wanted them to be off the wall so the light would come through and also you get the shadow.
How long does it take you to grind one of those pieces? Is it like a 10-minute thing or 3 hours?
Yeah, like a half hour, depending on how much. The larger ones take longer. Depending if I go back and do anything like this one's got some polish work in it. The glass is just like, it's like wood, you start with a rough grit, you work through to a finer grit. You want to come to a full polish, then you have to go to a cerium that's run on a felt pad. You load a felt wheel with cerium, which is polish and that will bring it to a high polish. Most of these aren't high polish because I wanted to actually have some of that frosting. So, yeah.
Questions? You got any questions?
How big is that room? That
It's
storm-
about 8 foot square in the, on the footprint.
It's roughly 6
Yeah, it's about-
bicycle trailer pulls.
No, we got it all down there. to pick up.
No, I mean, but you haul them here. Richard was biking over with a bike trailer full of windows. It's like rattling down the road.
So are they all curb?
Yeah. Yeah, it's like- a couple of them might have come out the house that, when I redid the ones, but I think most of them actually got. So. Yeah, I mean, glass is actually this incredible resource. You don't appreciate. Actually, how recent it is technology, and how much our mind will actually hinges on. There was an article recently in the New Yorker about this, but it was there, and she starts it out talking about Spruce Pine, North Carolina, which is where I used to order all my glass from, that I would melt. And it's one of the largest, that mine there is one of the largest producers of silver sands, they call it. It's highest quality silica sand, high purity, which they use to make silver chips. And this mine, they like, whenever they have somebody come in, it's they blindfold them. I mean, it's like, it's kind of weird, like the level of security that, you know, the global competition. It's basically one of the, I think the only line there that has that highest purity. So it's, yeah, as an artist, I think about these things, it's material.
With the fans spinning around, would they just randomly open the window, open and close the window?
Yeah, as they pass, they would like fly. Yeah, and so yeah, I just bolted them out. They put it on 2 bolts. There's the structure. So not all of them actually fit it. I just get them to reach everything. That's enough for the flat. Sure. And then I had an antique projector I had. It also comes on. Projects images taken from NASA.
Any other questions for Richard? I think Davie's got something there, and that's it.
Hi, my name's Davie, and I have a problem. I'm caught in an incestuous loop of work and hobby, and I come here and I volunteer my time, it's work and hobby related. So anyway, many moons ago, I work for Tormach, naturally. Many moons ago, over the years, this is a computer for our machine. And then they come back damaged, whatever, they collect up, eventually Chris gets them. So about a year ago now, I actually was looking through small pictures. About a year ago, I started taking them home and rebuilding them, just because I've done a lot of IT and computer repair in my life. So basically, I took like 30 of these home and grabbed all the parts that work and put them in the parts that don't, and threw some things away, and still have a pile in the corner of my garage. But all of this to say that now upstairs, there is 15-ish. I've used a few. We're going to try to put some on some of the machines here. Anyway, there's 15-ish of these steel-clad Linux boxes, and I really just wanted to show you all in case somebody can come up with a really cool idea for them. If you want one, talk to Chris. Like I said, there's a bunch of them up there. I put notes on the boxes for them. But ultimately, what you get out of the deal is a touch screen. This one, I actually put our control software in the simulation mode, if you can see it, because there's some of this that, I guess this isn't a light panel in simulation mode. I actually don't know how to put it into reset to get it, but this is like a 4-color, red, blue, green, and something else. Yellow, I think. Light panel, and then you've got some inputs and some buttons, and these buttons do various different things. And then also, besides that, let's see if I can get out of here. There it is. You have just a regular old Linux box. The theory is that if you wanted to, I've got like a really super long-winded, really low priority plan to make this a stereo, kind of my MP3 box for my garage, where I've got like, you know, a volume knob, and then I actually have an LED lighting system in the garage. So I want to, this would be like, you know, the color of the garage lights, and then this would be whatever else. That's never going to happen. I'm going to keep thinking about it and planning for it. Never going to actually happen. But ultimately, besides the, you know, kind of the Linux box factor,
You and Richard gotta get together. So you could do, you know, the digital thing, glassware.
Yeah. Yeah.
Windows.
You know, wall of Tormach.
That's what I'm saying.
Yeah. And so anyway, that's kind of my short spiel. I don't have a really long, this was many arduous hours of labor on my part, but really it was boring. It was like, oh, the hard drive on this one doesn't work. So put one of the other ones we pile in and see if that works. Anyway, so I just wanted to kind of wet everybody's whistle here and start digging around with these things. Like I said, there's a bunch upstairs.
How much does your music box retail for? We bought those from
With the mounting hardware is about $2,000. So this by itself is probably like $1,500 worth of device.
So what kind of video games you got on there?
Oh yeah. Do on there?
So my next
Long at least?
well, my next move that I haven't figured out, or I haven't put any time into yet, was to load a different Linux. Because right now this is a base load of Linux CNCs from 12 or 15 years ago or something like that. It's still reasonably current in that there's like Chrome on here and stuff like that. But anyway, because my buddy has done some of the legwork to get, you know, other loads of Linux on these, but we haven't messed with it in a while.
The x86 ARM, like what's?
I actually have no idea.
It's an x86.
I assume so, but I don't know any of the specs. I knew somebody was going to ask me that. And I was actually I meant to quiz Scott ahead of time because I'm sure I don't really know much about Linux. I'm sure there's a menu or a selection I can select somewhere to show, like, I don't even know how many gigs of RAM's in it. It's got 64 gig hard drive. That's all I know. And it's one of the what's the little chip base? It's not, it's an SSD, but it's the,
And it's the NVMe year. It's
it's NVMe and whatever that one was. Anyway,
the little stick.
it's the little, it looks like a piece of RAM, but it's a hard drive with 64 gigs.
You said you had 30 and you made 15.
Hey, I didn't call for an account.
Someone's paying attention to that. It seems like pretty good odds.
I actually, I was learning about this. I was doing the math as I was going, around about 70% efficiency. That 15 upstairs is less the 1, 2, 3, 4 that I've taken off the file.
Oh, so you're more like 60.
The 50, yeah.
The drift is high, yeah.
It's the one thing in this building I have no problems coming in and be like, I'm taking this one. I got like 90 hours into this project. One of those things you don't count.
He's also voluntold himself for work now because his work folks are like, well, you know, you can fix those, and he's like, yeah, if I build hourly, this
yeah, right, yeah, I get paid way too much to be messing with that. But yeah, so like I said, we're trying to, like, I'm putting one on the plasma here in the next couple weeks. Probably gonna start retrofitting some of the other even non-Tormach related machines, because the Path Pilot is our variant of the Linux CNC kind of UI. So people on the internet, some people in this building have kind of scabbed their own devices into this interface as well. So if you have like some homebrew CNC thing that you wanted to kind of mess with, then here's your opportunity.
This has the EtherCAT kind of connection, so there's no like Mesa card in there already for the I/O. It goes to a machine-based Ethernet connection.
Correct. Yeah, it's Ethernet to the ECM board. Yeah, so if you wanted to get frisky, you probably have to buy an ECM board from Tormach or from somewhere else to connect. And that's pretty, that gets to the edges of my knowledge.
Any other questions for Mr. Davie? He's doing Tormach tech support. If you got him after the meeting, any questions at all, I'm just bothering him. Nobody has all.
You guys are all so smart.
Thank you. But not really. I don't know, but someday it's not. You got time. You got it. Everything but time. I'm good on the attic or the computer rebuilding.
Yeah.
So the systems count for a lot.
Yeah, right.
I think that's stubborn.
Yeah. All right, thank you, Davey.
Yeah.
Let's see here. Jim, we're gonna punt to another night. I know you're gonna be disappointed.
Most of people have time to do more.
We will have time to do more. The only thing I was gonna share, somebody donated an old 3D printer this week, and I thought this has been around since like 2006. I had never seen one like this. I'm gonna hold it up here since the poor Zoom people are totally missing out on the entertainment here. I'll throw a YouTube video up in a second, but it's called a new better printer. So if anybody's unfamiliar, this thing's a glorified hot glue gun 3D printer. And this part here goes up and down, so the thing goes down towards this print bed, and the print bed moves around. The weird thing with this is that the print bed is not attached to the printer, yet it somehow still works. This has gear, like a rack drive on the bottom of the bed, and I don't think anybody else ever made one like this, but this is actually, these are the gears. So the motors spin, and then it moves the bed around, and you're using gravity to hold the bed in place up against the motors. Now, the reason nobody else did this is because it takes 4 times the build area of the printer base. Like the build area is really small for how big the printer is, but it's a super, super clever way of building a printer without really a lot of effort. So this was like the first sub $400 printer, I think is why they got popular. And so anyway, somebody donated it, and I was like, oh, go online, like look this thing up, like let's see what's out there. And so I pulled up their website, and if we load it, you know, the New Matter website there, and it's a personal care methodology. So you know, ready to get our shampoo on and our conditioner from the 3D printer company. So yes, the company is no more, but if you'd like some shampoo or conditioner, or get on their email list. Yeah, so it's kind of funny. So this is a defunct printer company. There's a lot of these printers out there. Just in general, there's a lot of printer manufacturers who made printers, and they are no more. So yeah, you'll run into these occasionally. People have figured out how to reslice models and print with it still, but this was just novel in the approach that they're using to move the bed. I hadn't seen anybody do that, which is pretty cool.
How would you rate the shampoo though?
Oh, I mean, you know, with the charcoal cleanser, I mean, it just cleans up the pores. It's great. Does anybody else have anything they wanted to share tonight? Otherwise, I think we'll go around and you can see who you are, what you're into, and go from there. All right, I'm gonna boot the Zoom people off. So thanks everybody for joining us.